This is class 23 of my Arithmetic course. Today we're going to be learning the order of operations agreement, and we're also going to apply this agreement to geometric formulas. If you haven't done the homework from class 22, do that homework completely and correctly and check all your answers before watching this video. Alright, as you can see, we have a rectangle here, and what we're going to do is find the perimeter of this rectangle. And you know, to find the perimeter, you add this side, which is 8, and this side, which is 8, and this side, which is 4, and this side, which is also 4. 8 plus 8 is 16, plus another 4 is 20, plus another 4 is 24. So we know the perimeter of this rectangle is 24. You've done that multiple times in this class. But today what we're going to do is we're going to learn a way to show other people how to find the perimeter of a rectangle or other shapes, area, volume, so on and so forth. We're going to show people what operations to perform by writing an expression, as you can see. So this is the expression to find the perimeter of a rectangle. And so let's go ahead and you can see we have multiplication and we have addition and another multiplication sign. So let's go ahead and do these operations. 4 plus 2 is 6. Then we're going to multiply 2 times 6 is 12. And 12 times 8 is 96. So as you can see, we got the wrong answer. So something went wrong here. We performed all the operations correctly, but we got the wrong answer. So now let's go down to this second formula here, the second expression. We have the exact same expression that we had up here, but now let's perform the operations, the addition and the multiplication, in a different order. Let's try multiplying first, because we added first in the above example. Let's try multiplying first, and we get 8. 2 times 4 is 8. 2 times 4 is 8. 2 times 8 is 16. And then after we multiply, then we add at the last step instead of the first step. 8 plus 16 is 24, and then we got the right answer. So as you can see, so wrong answer, correct answer. As you can see, the answer changes based on the order of the operations that you perform. So what we have to do is we have to come up with what's called an order of operations agreement, because when you look at these expressions, you see a bunch of operations, right? But there's nothing in this expression that tells you what order of operations you should follow. Should we do addition first? Should we do multiplication first? There's nothing in these expressions that tells us what to do. So again, mathematicians have come up with something called an order of operations agreement so that whenever a mathematician writes an expression, or an engineer or a scientist writes a mathematical expression, they all know which operations to perform first, so that they'll all get the same answer. So the whole point of this is to learn how to communicate mathematics to other engineers, scientists, or mathematicians. The most important part of this course and any other math course is learning how to read and write mathematics. We're learning how to communicate mathematics to other people. That's really what math is, learning how to communicate the math to other people. So we're learning how to write an expression, how to show people how to do something, and write that expression so that everybody knows exactly what that expression means. But again, the order of operations is not shown in these expressions, so we have to come up with an agreement. So because we multiplied first and then added and got the right answer, we're going to come up with an order of operations agreement that tells us to multiply first, then add. Whenever you see an expression like this, you're going to multiply first, then you're going to add. So now let's go down to example number 2. In example number 2, we're going to find the area of a trapezoid. Now you've already found the area of a rectangle. You know, you just multiply the length and the width. The area of this rectangle, for example, would be 4 times 8, which is 32 square units. But we're going to find the area of a trapezoid. this is called a trapezoid here. We've not learned trapezoids yet, but that's okay. And here's the expression. So I'm giving you an expression on paper to show you how to find the area of a trapezoid. And we've come up with an order of operations agreement that tells us to always multiply first, then add. So let's go ahead and do that. 10 times 3 is 30. And we haven't talked about division yet, but let's go ahead and just divide first before we add. 30 divided by 2 is 15. And 15 plus 5 is 20. And that's actually the wrong answer. 20 is not the area of the trapezoid. So our order of operations agreement didn't work in this case. But if we add first, 5 plus 10 is 15, and then 15 times 3 is 45, and then 45 divided by 2 is 22.5. That gives us the actual area of the trapezoid. That's correct. So our order of operations agreement did not work in this case. So what do we have? What do we do to solve this problem? Well, what we do is we just put parentheses around the 5 and the 10. And the parentheses tell us to violate the order of operations agreement. I need you, when you try to find the area of a trapezoid, I need you to add the 5 and the 10 first. That's just how you find the area of a trapezoid. That just happens to be the way that you do it. So I want you to add the 5 and the 10 first, but that violates the order of operations agreement. So I have to put these parentheses that tells you to violate the agreement. So again, the whole point of this is to show you how to it's to come up with a way to express mathematical formulas to show people how to perform the operations. Now, I just want to mention real quick that we can change the order of operations agreement. Because the big question on your mind should be simply this: why did we decide to multiply first, then add? Because in this example, we wanted to add first. Adding first, then multiplying and dividing, that actually gave us the correct answer. So if you followed addition first, then multiplication, you got the correct answer here. But if you followed multiplication first, then addition, you got the correct answer here. So why are we choosing multiplication first? Well, you don't have to choose multiplication first. You can make it addition first, and then if you made it addition first, you would have to put parentheses around the multiplication operations, so that you know to multiply first. You know to violate the order of operations. So we could do it either way. So why is it that all the mathematicians, engineers, and scientists around the world have decided to multiply first? Well, probably the reason they decided to multiply first is that there are just many, many more formulas that require you to multiply first. So that means that we don't have to write as many parentheses in our expressions. It just makes it easier. So that's your introduction to order of operations. So now that you kind of have hopefully an idea of what is going on here, again, this is all about just communicating the math to other people. It's learning how to read and write the math and express a set of operations on paper so that people will know what you're talking about. That's all this is. There's no mystery here. So let's go down, because we only talked about multiplication and division. So let's go down and see our complete order of operations agreement. We have PEMDAS here. That's an acronym. Each one of these letters stands for a word. And what this means is we're going to read left to right, and whatever letter is farthest to the left, that's the operation we perform first. So P is farthest to the left, so we do whatever's in the parentheses first, because parentheses tells us to violate the order of operations agreement. Then we do exponents, and we went over exponents of a little bit. We'll review those today. Then we do multiplication and division and addition, subtraction, so on and so forth. Now, we're going to talk about what these arrows mean later on, but let's just go ahead and get into our first problem here. So we have, again, we have multiplication and addition. And PEMDAS tells us if we're reading left or right, whatever comes left, or whatever comes first, reading left or right, we do first. So multiplication we do first, then we do addition. So multiply. 2 times 3 is 6. 6 plus 1 is 7. Now again, I could have added these first, then multiplied. I could have done that. But the problem is other mathematicians would get confused because that violates the order of operations. So again, this is just learning how to read and write the mathematics. All right, so why don't you try number 2. Remember, you have your PEMDAS here right in front of you. PEMDAS tells you what to do. Try number 2. Pause the video. When you come back, we'll do it together. All right, we're back. 9 divided by 3 is 3. 5 minus 3 is 2. Why do we do division first? Because it comes first, reading left to right, before subtraction. If you got the right answer, good job. Now we're going on to the next one. Now we have an exponent. So we're going to have to use the E in PEMDAS. Exponent first, then multiplication. Now if you forgot what exponents mean, 2 to the third power, I'm going to write it up here. Maybe you'll use a different color here. 2 to the third power is equal to 2 times 2 times 2. Now why are we multiplying 2 3 times? Because there's a 3 here. All right, no tricks here. So 2 times 2 is 4. I don't know why, but I find a lot of students have trouble with this, but 2 times 2 is 4. So we took these 2's and put them together to make 4. Then we take the 4 and multiply it by 2 again, and we get 8. So 2 to the third power is 8. Why did we do this part first? Because E comes first, reading left to right, before multiplication. So 2 to the third power is 8. And then we do multiplication next. 8 times 5 is 40. All right, so why don't you try number 4. And when you're done, we'll come back and do it together. All right, we're back. We want to do exponents first. 7 to the second power is 7 times 7, which is 49. So we did the exponents first. Now we're going to do division. That's what comes next. 15 divided by 3 is 5. And then lastly, we'll do subtraction. Reading left to right, that's the last letter in the acronym. 49 minus 5 is 44. So if you got 44, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so now we're moving on to parentheses. See, we have parentheses here. The parentheses tell us to violate the order of operations agreement. All right, so the order of operations tells us to divide before we add. We want to divide before we add. But because we see the parentheses here, that tells us to violate the agreement. Violate the order of operations agreement. So we're going to add first, then divide. So 5 plus 4 is 9. And because we're done with all the operations in the parentheses, we can get rid of the parentheses. And now we divide. 63 divided by 9 is 7. Right? And if you're having trouble figuring out what 63 divided by 9 is, that's because you didn't memorize your multiplication facts. You should recognize the number 63 and the number 9, because 9 times 7 is 63. So why don't you try number 6, and when you're done, we'll come back and do it together. All right, we're back. Do the parentheses first. 5 plus 3 is 8. 8 times 7 is 56. So if you got the right answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so why don't you do numbers 7 and 8, and when you come back, we'll do those together. All right, we're back. Parentheses first. 8 minus 4 is 4. Then multiplication. 3 times 4 is 12. And 1 plus 12 is 13. Again, how did I know what order of operations to follow? Well, I did parentheses first. Parentheses first. Then I did multiplication. Then I did addition. Remember, you can use that acronym to remember which operation to do first. All right, 1 plus 2 is 3, parentheses first. Now that we're done with the parentheses, notice I got rid of the parentheses because the operations inside the parentheses are done. Once you're done with the parentheses, you do the exponents. 3 to the second power is 3 times 3 is 9. And then 72 divided by 9 is 8. So if you got that one right, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. On to number 9. Now we're doing just more calculations here. So we do the parentheses first, but notice that in the parentheses we have multiple operations in the parentheses. You see that? We have exponents, we have subtraction. So when you go into parentheses and you have multiple operations within the parentheses, what you do is you just follow order of operations again within the parentheses. So order of operations tells us to do exponents first before we do subtraction. So 5 to the second power is 5 times 5 is 25. And then we do subtraction. We're going to continue in the parentheses because we're not done with the operations in the parentheses yet. We have to keep going with the parentheses. 25 minus 20 is 5. And now we're done with the parentheses, so we can get rid of those parentheses. We finished all the operations within the parentheses. And then we have exponents and subtraction. We have subtraction and exponent. We have to do the exponent first. PEMDAS tells us 5 to the second power is 5 times 5 is 25. And 30 minus 25 is 5. So why don't you do numbers 10 and numbers 11. And when you come back, we'll do it together. All right, we're back. We do parentheses first. And in the parentheses, you have multiple operations. So we're going to do the exponent first. 3 to the second power is 3 times 3 is 9. All right, and we have to keep going with the parentheses. So order of operations tells us to do division next in the parentheses. 100 divided by 10 is 10. And we have to keep going with parentheses. We're not done with the parentheses yet. Remember, parentheses first. So now we do 10 minus 9 is 1. And we can get rid of those parentheses because all the operations in the parentheses are now done. All right, so now the parentheses are gone, so we just follow order of operations on the outsides of the parentheses. So exponents first, 2 to the third power is 8. We already figured that out in a previous problem. Then 8 times 8 is 64. 64 plus 1 is 65. So if you got the right answer, good job. That was a long one. If you didn't, that's okay. Just go back and figure out what you did wrong. On to number 11. Parentheses first. But we have to follow the order of operations within parentheses. So exponents first, 2 to the fourth power is 16. And if you're not sure why 2 to the fourth power is 16, just remember 2 times 2 times 2 times 2. Why are we multiplying 2 4 times? Well, because there's a 4 there. You're taking 2 and you're multiplying it by itself 4 times. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. No big deal. All right, so we have to continue with the parentheses. Don't go on to this other stuff until you're done with the parentheses. 2 times 1 is 2. We have to do multiplication first. And then 2 plus 16 is 18. And now we have to do multiplication first. We get 15. 15 plus 18 is 33. So if you got that one right, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so remember we saw some arrows here on the acronym. Now we're going to talk about what those arrows mean. This acronym tells us to multiply first, then divide. All right? But it's actually not always true that you're going to multiply first, then divide. You're actually going to, whenever you have multiplication and division, the rule is you're always going to do whatever operation is farthest to the left first. So sometimes you'll see division farthest to the left, then multiplication going to the next operation to the right. So in that case, you'll have to divide first, then multiply. And sometimes you'll have to subtract first, then add. So the order in this acronym is not always the correct order. You have to move left to right. So let's talk about what we mean here. We have two expressions that are exactly the same. 8 divided by 4 times 2. Now again, the acronym tells us to multiply first. So look what happens if we multiply first. 4 times 2 is 8. And then 8 divided by 8 is 1. Now that's actually the incorrect answer. So that did not work. Now look what happens if we divide first. 8 divided by 4 is 2. And then 2 times 2 is 4. So you can see we get different answers here. So the rule is whenever you see multiplication and division next to each other, you always do whatever operation is farthest to the left. You always do that operation first. So division first, then multiplication. That's just the rule that mathematicians have come up with. Now I know what you're thinking. You're thinking, where did that rule come from? Well, there are some various reasons that they came up with it, but the most important thing to understand is we could do it either way. But mathematicians have decided that when you're writing these expressions, this is how you interpret the expressions. It's just showing people how to write the math down on paper so that other people will understand what you're trying to tell them to do. That's all we're doing here. All right, this is not the order of operations is not intrinsic in the math of the universe. If you go to another planet where let's say that there are aliens on another planet, they may use a different order of operations, and they may use parentheses to violate that order of operation in the opposite direction. So it just really doesn't matter. We're just choosing this way because it works best for our the applications that we use on this planet. All right, so let's go on to subtraction and addition. The same thing is true for subtraction and addition. You see these arrows in subtraction and addition? So we have cases where we have subtraction and addition here. We have the same expression written twice. But in the first expression, we're going to add the 3 and the 1 first. So we're going to do what's on the right. We're going to go right to left. So 3 plus 1 is 4. And 7 minus 4 is 3. So that is actually not correct because we went right to left. The agreement tells us to go left to right. 7 minus 3 is 4. And then 4 plus 1 is 5. That's correct. It's only correct because it's proper math notation. It's like if you're going to say, I need to go to the store, you don't say, I store need to go. It's just, it's not that it's wrong, it's just that people aren't going to understand. When I say it's not that it's wrong, if you're trying to convey a point, you know what you're trying to say, but if you can't communicate it to other people, then speaking the words is meaningless. The whole purpose of speaking is to communicate to other people. All right, so let's do a couple problems here. So as you can see, we have multiplication and division. Let me zoom in here. Whoops. So again, when you have multiplication and division, you have to move left to right. Do the operation on the left first, then the next operation, then the next operation. But don't move right to left or else you get the wrong answer. 64 divided by 8 is 8. And then we still have to move left to right, so 8 times 5 is first, moving left to right, we get 40, and 40 divided by 10 is 4. Now we have subtraction and addition. Again, if we move right to left, we're going to get the wrong answer. Or if we do the middle operation first, then the side operations, then we're going to get the wrong answer. You have to move left to right. So 10 minus 2 is 8. 8 plus 4 is 12. 12 minus 1 is 11. All right, so why don't you try numbers 16 and 17, and when you come back, we'll do those together. All right, we're back. 3 times 10 is 30. 30 divided by 5 is 6. 6 times 5 is 30. So if you got the right answer, good job. All right, now we have addition and subtraction. 4 plus 9 is 13. 13 minus 2 is 11. 11 plus 2 is 13. So if you got that one right, good job. All right, so now we're going to use this left to right rule in these next problems. But things are just going to get a little more complicated. So we have to do parentheses first. PEMDAS tells us parentheses first. And we have to follow order of operations within the parentheses. So we have to do multiplication first. 20 times 2 is 40. And now we have subtraction and addition inside the parentheses. So we have to move left to right. Do the operation farthest to the left first, which is 62 minus 40, which is 22. And I did that in my head, but if you don't want to do that in your head, you can do it off to the side here. 2 minus 0 is 2. 6 minus 4 is 2. But you can probably do that in your head. Now 22 plus 8. 8 plus 2 is 10. Carry the 1. 2 plus 1 is 3. But again, these are things that you can really do in your head. Now that you've been doing these operations for quite a while, you can start to do some of the stuff in your head. You're gonna find that as you go along in math, you're gonna need to start to do calculations quicker and quicker. 22 plus 8 is 30. And 30. So now we have division and multiplication. So we have to do the operation farthest to the left first. That's where the arrows come in on PEMDAS. 30 divided by 10 is 3. And 3 times 4 is 12. Let's see here. So why don't you try the next 3 problems, and when you're done, we'll do them together. All right, we're back. Do parentheses first. 6 minus 3 is 3. And why did I do the subtraction first? Because it was farthest to the left. If I had done the addition first, I would have gotten the wrong answer. We have to keep going with the parentheses. And now that we're done with the operations in the parentheses, we can get rid of the parentheses. All right, so the parentheses are gone, so now we just follow the order of operations. But you see here we have division and multiplication. So we have to do the operation farthest to the left first. 77 divided by 11 is 7. And at this point, you can actually do both of these operations at once, the multiplication. But just to keep things simple, let's do it one step at a time. 7 times 9 is 63. And just to keep that rule, we'll move left to right. 4 times 8. 4 times 8 is 32. And 63 minus 32 is 31. So if you got the right answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, parentheses first. And we have to follow the order of operations in parentheses. 2 to the second power is 2 times 2, which is 4. And now again, we have addition and subtraction within the parentheses. So you have to do the operation farthest to the left first. If you add first, you're going to get the wrong answer. 4 minus 1 is 3. Keep going with the parentheses. 3 plus 6 is 9. And all the operations inside the parentheses are now done, so we can get rid of the parentheses. But now look what we have. We have 2 multiplication signs and a division sign. So we have a lot of multiplication and division together. So what do we do here? Well, we have to move left to right. 4 times 9 is 36. 36 divided by 9 is 4. And now we're done with all that division and multiplication. Again, we did this operation first, then this operation, then the last operation, moving left to right. 4 times 8 is 32. 32 plus 1 is 33. So if you got the right answer, good job. Let's go on to the next one. Let me just double check that work. Pretty sure that's correct if I wrote all that stuff down correctly. Let's see. Parentheses first. 3 to the third power. 3 to the third power is 3 times 3 times 3 is 27. (27) divided by 9. We have to do the division first because we're going left to right. (27) divided by 9 is 3. Then we're still going with parentheses. 3 times 2 is 6. And multiplication first. 5 times 6 is 30. Now we have subtraction and addition. So which one do we do first? Well, we do whatever is on the left side first. So 10 minus 3 is 7. And 7 plus 30 is 37. So if you got the right answer, good job. If you didn't, that's okay. Just go back and figure out what you did wrong. All right, so now we have two problems where we have square brackets. We haven't seen square brackets. So why are the square brackets there? Well, the purpose for the square brackets is when you have a set of operations where you have to violate the order of operations, so you have to use parentheses, and the brackets tell us to perform all those operations first. So all it is a more complicated expression. When you have a lot of operations here, and some of the operations require parentheses, and you want all of those operations to be performed first before you add the 7 or do whatever you're going to do to all these operations, you put brackets, and that just tells you to do all these first. But the reason that we don't use parentheses again is because if you keep using parentheses over and over again, like so, then eventually it would get really difficult to differentiate between all these different parentheses because they all look the same. So we use a different shape for the second set of parentheses. And these are called, again, rectangular brackets. And then if we had to use another set of parentheses, we'd use curved brackets. They look like so, but we're not going to get into that in this class because that's kind of rare to have to use curved brackets. The calculations aren't going to be that complicated. So do the brackets first. So we're going to do all this stuff first. And inside the brackets, we're going to follow order of operations. So parentheses first, 2 minus 1 is 1. And keep your brackets. We don't get rid of the brackets until we're done with all the operations inside the brackets. But we're done with the operations in the parentheses, so we get rid of those parentheses. 1 to the third power is 1 times 1 times 1. So 1 times 1 is 1, times another 1 is 1. If we do a little factor tree there, a reverse factor tree. So 1 to the third power is 1. You know what, I'm going to rewrite these brackets so I'm using just one line here. 1 to the third power is 1. And we have to do multiplication first. 1 times 6 is 6. 8 times 6, we have to keep going with the brackets. 8 minus 6 is 2. And because we're done with all the operations in the brackets, we can get rid of the brackets, and 2 plus 7 is 9. So if you got the right answer there, good job. If you didn't, that's okay. Just figure out what you did wrong. Actually, we did that one together, so I don't know why I'm telling you that. The next problem, now you try the next problem. Pause the video, and when you come back, we'll do it together. All right, we're back. 5 minus 3 is 2. And 2 to the second power is 4. And we can go ahead and just add all these numbers together. We don't really have to worry about moving left to right or doing it step by step. So 4 plus 4 is 8, plus another 1 is 9. And I know I've been doing just one step at a time up until now, but when you have all the same operation here, and it's addition or multiplication, you can just go ahead and multiply all those together. But if this were subtraction, that would be a completely different story. You would have to subtract 1 minus 4, then subtract 4 again, so that would be different. So hopefully I'm not confusing you by doing all those two additions signs at the same time. All right, so 72 divided by 9 is 8. 8 plus 5 is 13. So if you got the right answer, good job. If you didn't, that's okay. Figure out what you did wrong. All right, so that's the order of operations agreement. And those are hopefully enough problems for you to get the idea of how this stuff works. So now in the remainder of this class today, we're going to be applying the order of operations agreement, because you're probably thinking to yourself, you know, why are we doing this? Why are we trying to communicate these expressions? Well, remember, we gave examples where we were communicating operations that related to geometry. Geometry is one of the most important applications of order of operations. Of course, there are just thousands and thousands of applications for what we're doing. All we're doing is just expressing math to other mathematicians, engineers, and scientists on paper. So there's all kinds of things we can do to show applications for the order of operations, but we're going to focus on geometric formulas today, because geometry is extremely important in your math education all throughout every course you're going to take. So we're going to learn a lot of geometric formulas today, and you can see we found the perimeter of a rectangle using a formula. And again, we already knew how to find the perimeter, but we learned how to express to other people how to find the perimeter. And we learned how to find the area of a trapezoid. And that's the first example we're going to do down here. We're going to come up with a formula to find the area of a trapezoid, and here's the formula. So let's talk about what a trapezoid is. A trapezoid is a four-sided figure, also called a quadrilateral. Quad meaning four. And you see we have four sides, and a trapezoid is a quadrilateral where you have one pair of parallel sides. So that means this side and this side are parallel. And what parallel means is that they're going in the same direction, and they're never going to cross. Now these sides, they're not going in the same direction because they're going to cross. They're going to cross at this point here. But these sides, they'll never cross. So that's what parallel means. These sides are parallel. And these sides are called the bases of the trapezoid. So you can see we want to add the bases together first because they're in parentheses. And this number, this is called the height, this length here. This dotted line, the length of this line is called the height. So B1 is the length of this line, B2 is the length of this line, and H is the length of this line. Now I'm calling these lines, but technically they're not lines, they're actually segments. But the word that's most commonly used to describe any kind of length is a line. But you're going to learn in geometry that a line actually has a more precise definition. So this formula tells us how to find the area of that trapezoid using the height and the two bases. So let's go ahead and use this formula to find the area of the following trapezoid. You see this trapezoid here? Problem number 24 says find the area of the trapezoid below. So we're going to use our formula. Now listen very carefully. When you're going to use a formula in school or any kind of academic setting, when you're going to use a formula and show somebody else what you're doing, you have to write the formula that you're using. A equals B1 plus B2. So I'm just rewriting the formula. Whoops. I'm just rewriting the formula that we saw in the previous page. And the reason that you have to rewrite the entire formula is you have to show people what tool you're using to find the area of the trapezoid. You can't just start writing a bunch of numbers down here because people are going to wonder how you know to use those numbers and those operations. Well, obviously we know we're going to be using these numbers, but how do you know to use those operations? Well, this tells us we're using this tool. So it tells the reader what you're using. So you have to write the formula down for every single one of these problems. And if you don't write the formula down in the academic world, in school, your teachers are going to take points off because you're not explaining what tool you're using to solve this problem. And I know what you're thinking. You're thinking, I don't want to write that formula. I don't want to have to rewrite it because I don't need to rewrite it. But again, you have to understand that every math course, it's not about what you need. It's about you communicating the math to other people. That's the primary objective of this course. I know you don't believe me, but that's what math is all about. There's a lot of people out there that just don't understand that. If you have any experience in math courses at all, you know that's the primary objective of any math course. It's people think the primary objective is the calculations, but your brain can do these calculations pretty easily. It's really learning how to read and write the mathematics that is the most difficult thing in any math course. That's the primary objective. So now we've written the formula down, and I want you to do that every single time, even if you don't want to do it. I want you to write that formula before you do anything, or whatever formula you're going to use. So now we have our formula. We're going to plug in the numbers. So base 1, you can consider this to be base 1 or this to be base 1. It doesn't really matter which one is which in this case because they're both bases. But base 1 we'll say is 5, base 2 is 3, and the height is 2. That's this number here. And then we divide by 2. So now we have an expression that uses order of operations. So we just follow the order of operations, parentheses first. Then we have multiplication and division. So we have to do the operation that comes that's farthest to the left first. In this case, because you have multiplication farthest to the left first, it actually doesn't matter which operation you do first. It's not going to affect the answer. But remember, just keep that rule. Move if you had division first, then multiplication, and you didn't do it in the right order, then you get the wrong answer. But you don't have to remember that. All you have to remember is just move left to right when you have multiplication and division. So multiplication first, then division, and you get 8 is your final answer. Whoops. So let's see here, 16 divided by 2. All right, so if I write 8 as the final answer, I'm going to get 1 point taken off because I have to write the units. We have units here, and they are meters. And I have to also know that because we're finding area, the units are not going to be meters, they're going to be square meters. So I have to put a little 2 there. That means square meters. All right, so that's going to the next example. We have the perimeter of a rectangle written as a formula. So that's the formula to find the perimeter of a rectangle. Now again, you already know how to find the perimeter of a rectangle. You don't need to use this formula. But if you're going to try to communicate how to find the perimeter of a rectangle to somebody else, you have to figure out a way to write it down. So how do you do that? Well, that's what we've learned today with order of operations. We've learned how to write these formulas down and to follow the correct order of operations so that every engineer, scientist, and mathematician gets the right answer no matter what, no matter who's doing the calculation. So I want you to do number 25. 25 says find the perimeter of the rectangle below by using the perimeter formula. So again, you already know how to find the perimeter, but I want you to use this formula. So the first thing that you do is you rewrite this exact formula down here. Before you do anything else, you copy this exact formula because that tells the reader what tool you're using. And then you plug in the numbers and you do what's called evaluating. I didn't mention that in the previous problem. When you evaluate, you plug in the numbers and then you perform the calculations. That's called evaluating in math. So they give you certain numbers, then you plug them in and you calculate. That's called evaluating the expression. So I want you to write the formula down and then evaluate by plugging in the width and the length and then calculating the answer. Now, the perimeter is just one-dimensional, so your answer is not going to be square feet. It's just going to be regular feet. So try that problem, and when you come back, we'll do it together. All right, we're back. We're going to rewrite the formula. I'm just rewriting the exact formula. If you didn't do that, you didn't do it correctly. And now we're going to plug in the numbers. W is the width. That's going to be 6. And L is the length. That's going to be 2. So now we plugged in the numbers. We showed the tool that we're using. We plugged in the numbers. And now we're going to evaluate by performing the order of operations. Order of operations tells us to multiply first, and I'm going to go ahead and do 2 steps at once here. So we multiplied first. Then we're going to add them together to get 16. And if you wrote 16 as your final answer, you'll get 1 point taken off because you have to write FT for feet. Always write your units. All right, now we're going to find the area of a triangle. I want you to go ahead and do this problem also. Remember, the first step is to, well, first of all, let's talk about this formula a little bit because we haven't found the area of a triangle. I think we may have had one practice problem for this a ways back. So the bottom part of the triangle, well, first of all, you can set a triangle on any side. Whatever side you set the triangle on, that becomes the base. But I'm going to set the triangle on this side, so that's the side we're going to call the base. That's B. And the height is the distance from the base to the very top of the triangle. So that's this length. So to find the area of a triangle, you take the base, multiply by the height, and then divide by 2. It doesn't matter what type of triangle it is. It could be a triangle that looks like this, and the height would be this distance, and the base would be this length here. It doesn't matter what type of triangle it is. You could have a triangle that is what an isosceles triangle, where 2 sides are the same. These 2 sides are the same. It doesn't matter. You always multiply the base and the height and divide by 2, and you'll get the area of the triangle. And if you're wondering why that is, don't worry about that now. That's advanced math, compared to this level. You don't have to worry about where any of these formulas come from in this class. The only purpose of learning the geometric formulas, or there's two reasons for learning the geometric formulas. One is to practice your order of operations agreement and see how they're applied, and the second reason is you're gonna need these formulas, and you're gonna need to start getting practice with them, because you're gonna see these formulas on all kinds of standardized tests and placement tests and all kinds of crazy stuff. All right, so area of a triangle. You see your formula there. The first thing you're going to do, the very first thing you're going to do is rewrite that formula. Write it again. So try number 26, and when you're done, we'll do it together. All right, let's try 26. So area of the triangle is equal to base times height divided by 2. I just rewrote the exact formula, exact same formula as we had up there. So now I'm going to plug in the numbers. The base is 6, the height is 3. And then I'm going to follow order of operations. We have multiplication division, so we do the operation farthest to the left, which is multiplication. 6 times 3 is 18. And then 18 divided by 2 is 9. So if you got 9, good job. If you didn't, that's okay. Just figure out what you did wrong. But this is not our final answer. If you write 9, you get 1 point taken off. We have to write inches. And because it's area, we have to write inches squared. Because area is measuring squares. How many squares can you fit inside? Area is 2-dimensional. Whereas the perimeter was only 1-dimensional. Actually, this part wouldn't really count because that's outside the triangle. See, the perimeter, we didn't need squares because we're just measuring the length. Length, you don't need squares to measure it. But area, you're measuring how many squares you can fit into a certain space, like a flat table or the flat ground or something like that. All right, so in all the previous geometric or the problems that we just did where we used geometric formulas, we didn't really have very, very difficult calculations. But now we're going on to some problems where we're going to use decimals. And you're probably thinking, oh no, we got to go back to decimals and do all those sophisticated calculations. The purpose of this class isn't really to review those calculations, but this is a good chance to review those calculations. But I want you to focus on the order of operations. That's the purpose of what we're doing here. So don't get nervous or depressed because we're having to review the decimals and multiplying and dividing decimals, and we're going to have, I think, one problem where we're going to multiply fractions. Don't worry about that. We're going to review all that stuff later on in this class. The most important thing to focus on is the order of operations. So, but we are going to do some review here of multiplying and dividing decimals. And we're going to do one problem where we multiply the fractions. And we're going to do more sophisticated operations with geometry later on. But I don't want to throw too much at you at the same time because I know it's going to make you nervous, even though you've already done all these operations previously. So now let's move on to area of a circle. Now, this is the area formula. And notice we have squiggly lines. That means the area is approximately equal to 3.14 times r squared. Now r is the radius. The radius is a line segment that goes from the center of the circle to a side. And this tells us that if you plug in the radius to this formula, you can find the area of the circle, which gives us an approximate measurement of how many squares you can fit into the circle. It's a measure of the space inside the circle. So the reason that we use the approximate sign is because this number pi. Well, actually, let me just tell you the real story here. The reason that we have an approximation is because squares don't fit into curved areas. Okay, you're never going to fit squares perfectly into the curved areas. what you're going to have to do is make these squares smaller and smaller and smaller, and then add up an infinite number of them to fit in. So that's why this is an approximation. This number is called pi, and you may have heard that number before. Whenever you have any formula, anything that relates to any kind of circle, you're going to have that number pi as a factor. Pi is a what's called a non-repeating decimal. It just goes on and on and on forever. But we can't write the entire number. It's actually impossible to write the entire number, so we're just approximating it as 3.14. All right, so let's try the first problem with area of a circle. Let me see here. Let's make sure we're doing this in order. Find the approximate area of a circle with radius 4 kilometers. All right, so let's write down the formula. Before you do anything else, write down that original formula. And we're told that the radius is 4, so we're going to plug in the numbers. So we plugged in 4. And now we just follow the order of operations agreement. So if you remember how to multiply, because we're going to multiply pretty big numbers here, if you remember how to multiply a 3-digit number times a 2-digit number, and you remember where to put the decimal, you can go ahead and do this yourself. If you don't remember, we can do it together. So go ahead and try this. If you want to try it yourself, pause the video, and when you come back, we'll do it together. All right, we're back. Follow the order of operations agreement. First, you do exponents, so 4 times 4 is 16. And then we're going to have to multiply 3.14 times 16. So we go over here to the side. And so here we're going to review multiplying decimals. So remember, when you're adding and subtracting decimals, you have to line up the decimal. So if I were adding 3.14 to 16, I would have to put the 16 here. Now, why would I have to do that? Because the decimal on the 16 is right there. Now, why is the decimal there? First of all, why was the decimal invisible in the first place? There's no decimal on the 16, right? But we learned in the previous classes that whenever the decimal is invisible, it's always one place or directly to the right of the number in the ones place. So it goes right there. So if we were adding these numbers, we'd have to line up the numbers like so. But because we're multiplying, we don't really have to line up the decimals. By the way, it's adding or subtracting, you have to line up the decimal. If you're multiplying, we don't have to line it up. But it is traditional to go ahead and line up the numbers like so when you're multiplying. So now let's review how to multiply these numbers. I'm going to space this out a little bit more, sorry. So it's not so cramped. All right, so we're going to start with the 6 and multiply the 6 by all these numbers. 6 times 4 is 24. 6 times 1 is 6 plus 2 is 8. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. All right, so we multiplied 6 times all these numbers. Now I'm going to erase this too so it doesn't confuse us because we're going on to the next number. Before we do anything, whenever we go on to the next number in the bottom row, we always put a placeholder, and if we go on to another number, we put 2 placeholders and then 3 placeholders and so on and so forth. But we only have 2 numbers, so we only need 1 placeholder. Now we're going to multiply 1 times all these numbers. 1 times 4 is 4, 1 times 1 is 1, 1 times 3 is 3. Then the last step of the algorithm, if you recall, first of all, we have to make sure that these numbers are all lined up. If these numbers are not lined up, then it's a guarantee that you're not going to get the correct answer. Again, we're just reviewing how to multiply decimals. And if you already remember how to multiply the decimals, you don't have to listen to this huge explanation here. 4 plus 0 is 4, 8 plus 4 is 12, carry the 1, 8 plus 1 is 9, plus 1 is 10, carry the 1, 3 plus 1 plus 1 is 5. So we have 50.24. But I said 50.24, but how did I know the decimal goes here? Well, remember the rule for multiplying decimals. First, let's put our decimal in the 16. There are 2 digits to the right of the decimal in this number and 0 digits to the right of the decimal in that number. So the total number of number of digits that we move the decimal is 2 plus 0. 2 plus 0 is 2. So we move the decimal 2 times, or 2 places. So we always start farthest to the right, right here, and we go 1, 2. So that's how I knew where to place the decimal. Again, this should all be review for you. If you don't remember it, that's okay, but this should start to become familiar. So that's our final answer. The area is approximately equal to 50.24. So I'm going to double check my answer there, because I was talking a lot while I was doing that. Yep, that's correct. So, let's see here. Now, if I write 50.24, I'll get 1 point taken off. You know why? Because this is area, so we have to say kilometers squared, or square kilometers. All right, so now let's go on to, whoops. Sorry about that. This thing jumps around randomly for no reason sometimes. So now let's go on to number 28. Now, number 28, you can see it's a challenge problem. It's just a challenge because there's a lot of more difficult calculations here. So now we're going to find the volume of a sphere. A sphere is like the shape of the Earth. It's a circle, but in 3 dimensions. So this is my attempt to draw a sphere. I'm not that great of a drawer, but that's a sphere. And the radius of the sphere is the distance from the center to one side of the sphere, just like the radius of a circle. And this is the formula to find the volume of a sphere. Now, you're probably wondering, well, what is volume? Well, we haven't really talked about volume in this class, but volume is 3-dimensional space. So if you wanted to measure the 3-dimensional space of this sphere, then what you could do is you could take like ice cubes, and you could put the ice cubes inside the sphere, and you could count how many ice cubes you can place inside the sphere, and that tells you the volume of the sphere. So with 1-dimensional space, when you're measuring length, you just get your ruler out and you measure the length. But when you're measuring an area like the floor, for example, the floor of maybe your room, you have to measure that in squares, figure out how many squares you can fit in your room. But when you're measuring 3-dimensional space, like the actual space in your room, all the space, including the height of the room, then you have to measure with cubes. For example, ice cubes. You figure out how many of these cubes you can fit in the space. So that's volume. So as you can see, the volume is approximately equal to 4 times 3.14 times the radius cubed divided by 3. So number 28, you can go ahead and try to try that problem. But again, there's going to be a lot of calculations here, so if you get stuck, just push play and we'll do it together. But you can go ahead and try this problem if you want, or you can just do it with me, pause the video, and when you come back, we'll do it together. All right, we're back. The most important thing is to rewrite the formula. All right? Because you're showing the reader what tool you're using to find whatever quantity you're trying to find. All right, so we rewrote the formula. All right, so now we're going to plug in the numbers. In this case, there's actually just one number, the radius. The radius, we're told, is 2 centimeters. So we plug in 2. All right. And now we just perform we perform the order of operations. Order of operations tells us to do the exponents first. 2 to the 3rd power is 8. And now we have multiplication and division. So whenever we have multiplication and division, what do? We always perform the operation farthest to the left first. So that's 4 times 3.14. All right, so let's go off to the side. We already multiplied decimals in the previous problem, so hopefully you can do this. And there are 2 digits to the right of the decimal here and no digits there. So again, we just like the previous problem, we move 1 or 2 places over. So we have 12.56. 12.56. And again, we want to move left to right. So now we do the multiplication. So let's do that over here, 12.56, and again, it's just the same, we're just multiplying decimals, so you already know how to do that. And the decimal again goes 2 places over, because we're multiplying by a whole number, so there's no digits to the right of the decimal in that number, but 2 here, so we move 2 places over. Let me just double check that, make sure that's correct. Looks correct. And now we're ready to do the division. So you can see why this is kind of a challenge problem, because you're just having to do a lot of calculations. So now we have to do division. So now we're going to review dividing decimals. So we have, you know what, I'm going to shrink these a little bit and get them out of the way. But you want to organize your work properly. So we're going to put a little divider line here to just show that we're doing work over to the right here. So now we have 100.48 divided by 3. We're using the long division algorithm. And again, if you don't remember this stuff, that's okay. We're reviewing it, but it should start to look familiar as we go through. So division cycles. There are cycles, and each cycle has 3 steps. Remember that? So the first step, how many times does 3 go into 1? It doesn't go at all. So now we have to say how many times does 3 go into 10? And if that doesn't go, we have to figure out how many times 3 goes into 100, and so on and so forth. But 3 does go into 10. It goes 3 times, because 3 times 3 is 9. It doesn't go any more than 3 times. But notice I put the 3 here. I did not put the 3 above the 1. The 3 has to go above the last digit of the number that you're dividing into. If you put it here, you're going to get the wrong answer. So that's the first step. Second step, 3 times 3 is 9. Third step, 10 minus 9 is 1. So that's one entire cycle. 3 steps for the first cycle. Now we're going to bring down the 0. And we start the whole thing over again. The only difference is we're trying to figure out how many times 3 goes into this number, as opposed to figuring out how many times it goes into number here. 3 goes into 10. We already figured that out. It goes 3 times. 3 times 3 is 9. Subtract 9 from 10 and you get 1. That was the second cycle. Each cycle has 3 steps. Now we bring down the next number. The 4 comes down. And we do it again. How many times does 3 go into 14? 3 times 4 is 12. 3 times 4 is 12. That's the second step. So the first step is putting the number here. The second step is actually multiplying. And then the third step is subtracting 12 from 14, which is 2. That's the third cycle. Now we're going to bring down the 8. How many times does 3 go into 28? It goes in 9 times. 9 times 3 is 27. 28 minus 27 is 1. Now, we know how to work with decimals, so whenever you have a remainder, we have to keep going. So you're going to add a 0 and bring it down. How many times does 3 go into 10? It goes in 3 times. 3 times 3 is 9. And remainder is 1. So we have to add another 0. We just keep getting another remainder. And as you go along here, you're going to find we're just going to do more and more 3s. 3, 3, 3, 3, 3. So it just keeps going on and on and on, because we keep getting a remainder of 1 over and over and over. So at this point, if this divisor were a decimal, let's say that this divisor were 0.03, then we'd have to figure out how many times we move the decimal to get to this line, and then however many times we move that decimal, we'd then have to move this decimal that same number of times and then bring it up. Remember that? But because this number is not a decimal, or technically the decimal is there, but it's already next to the line, because remember the decimal is directly to the right of the number in the ones place, and 3 is in the ones place, so the decimal is right there. Because it's already next to the line, it's a whole number, 3 is a whole number, we just bring this decimal straight up. We don't have to move it. We don't have to move it any places over, so it's just 33.49. So let's go ahead and write the final answer. 33.49, and the 3 goes on forever, so we have to put a bar there. So that was kind of a challenge problem because we had a lot of numbers, but before we do anything, before we go on, before we forget, we have to write the units. So the units are centimeters, and this is volume. So when you have volume, you write a 3 there. That means cubic centimeters. And why is it approximately? Whoops, I should draw that again. Why is it approximately? Because, again, you can't fit cubes into a sphere because cubes have they're cubes. They have sharp corners, but the circle doesn't have sharp corners. It's a curve, so it's always going to be an approximation. But you don't really have to know that. That's just for your information, if you're wondering. All right, so that's some good stuff there. We've learned order of operations. We've learned how to apply the order of operations to geometric formulas. We've learned all kinds of stuff. So what we're going to do in the next problem is we're going to learn how to find the volume of a rectangular prism. We learned how to find volume. That's our introduction to volume. That was kind of a difficult introduction because the volume of a sphere is not quite simple. But we introduced the concept of volume. So now we're going to go to an easier problem. And in this problem, we're not really the purpose of learning how to find the volume of a box is to just show you a really important formula. This is a really important formula, but you don't really need the order of operations agreement for this formula because it's just a bunch of multiplication operations. So the purpose of this is not really to teach you order of operations. The purpose is to just go ahead and show you the most important geometric formulas because we're learning geometric formulas today. So now we're just going to learn a formula just for the sake of learning the formula. Now a box has a fancy name. Mathematicians give this box a fancy name. They call it a rectangular prism. That's what this is called. So to find the volume of a rectangular prism, you take the length and the width and the height, and you just multiply them all together. So let's do an example of that. We're going to do quite a few examples because that's a really important formula. Find the volume of a rectangular prism with the height 8 feet, length 6 feet, and width 5 feet. So let's write the formula down. Before you do anything else, you have to show the tool that you're using. And I don't know which one I wrote here. Length, width, height. Doesn't really matter which one you write first. All right, so now we've written the formula. We plug in the numbers. The length is 6, the width is 5, and the height is 8. And it doesn't really matter which one you multiply first because it's just it's all multiplication. But just to keep the rule that we've used, we're going to multiply starting with the operation farthest to left. So 6 times 5 is 30, and 8 times 30. Remember, when you're multiplying a single-digit number by a two-digit number, and the two-digit number has a 0 on it, that's pretty easy because all you have to do is multiply 8 times 3 to get 24, and then add a 0. All right, so we learned that. We went over that briefly. If you don't remember it, that's okay. But you're going to have to start to get to get this stuff, because that is an operation you can do very, very quickly. So you don't want to have to set it up over here and do all that stuff, because it just takes time and energy. Wait, I didn't do that correctly. There we go. All right. So 240. So if I write that answer, I'm going to get 1 point taken off. Why am I going to get 1 point taken off? You tell me. You should know this. I'm going to get a point taken off because I didn't write feet cubed. I'm counting cubic feet. So there's 240 cubic feet in that rectangular prism, that box. Again, a rectangular prism is just like a box. All right, so in the next problem, we have the same thing. Find the volume of a room in the shape of a rectangular prism with dimensions 1.7 meters by 0.89 meters by 2 meters. Now notice this terminology here. We're saying length by width by height. When you say length by width by height, that's just another way to list the dimensions. No big deal. And it actually doesn't even tell us which one is length or which one is width or height, because it really doesn't matter. If you multiply in any order, you're going to get the same answer. Now that would not be necessarily true if it were division, but that's a rule that works for multiplication. And so you can multiply in any order. We're going to give a name for that later on in this class, but I'm not going to make you learn that now. So let's go ahead and do this. Write the formula that you're going to use. You got to show the tool that you're using, then plug in the dimensions. Again, it doesn't matter which one is which here. All right, and as you can see, we're multiplying decimals. So just to keep the rule going here, we're going to multiply these first. So 1.7 times 0.89. I don't have to line up the decimal. 7 times 9 is 63. 9 times 1 is 9, plus 6 is 15. Put a placeholder. 8 times, get rid of that 6, so it doesn't confuse me. 8 times 7 is 56, carry the 5. 8 times 1 is 8, plus 5 is 13. And make sure that these numbers are lined up. That's the number one source of error for most students. Now we're going to add these two numbers. 3 plus 0 is 3, 5 plus 6 is 11, carry the 1. 3 plus 1 is 5. 1 plus nothing is 1. Now, we have 1 digit to the right of the decimal here, and we have 2 digits to the right of the decimal here. So that's 1 plus 2 is 3. We're going to move the decimal 3 places. So you always start here, over here, and you move 1, 2, 3, because it's 1, 2, 3 digits to the right of the decimal. So 1.7 times 0.89 is 1.513. All right, so now we're going to multiply 2 times 1.513. We'll do that over here. You can almost do that in your head if you really want to do. 2 times 3 is 6, 2 times 1 is 2, 2 times 5 is 10, carry the 1, 2 times 1 is 2, plus 1 is 3. And where do you put the decimal? You tell me. There are 1, 2, 3 places to the right of the decimal here, and no places to the right of the decimal here. So you go 1, 2, 3. So our final answer is 3.026, and remember to write the unit. It's meters, but it's volume, so it's cubic meters. Got to put the 3 there. All right, so why don't you try the next problem? The next problem is going to have numbers that are a lot easier. Remember, the most important thing is to show that tool that you're using. Write that formula before you do anything else. Try number 31, and when you come back, we'll do it together. All right, we're back. We're going to show the formula we're using. Now we're going to plug in the numbers. The length is 8, but it doesn't really matter what the order is again. Height is 7. 8 times 3 is 24. And then 24 times 7, you can do that off to the side if you want, or you can try to just do it in your head. 168. And if you wrote 168, you get a point taken off because you didn't write cubic centimeters. But if you got the right answer, good job. If you didn't get the right answer, that's okay. Just figure out what you did wrong. All right, now in the previous problem, we showed that you can name the dimensions of a rectangular prism, or otherwise known as a box, by saying, whoops. Sometimes my paper just disappears there for no reason. You can name the dimensions by saying length by width by height. You can use that by word there. But there's another way to write the dimensions of a rectangular prism. You can say 7 times 8 times 21. You can use the times symbol, but this is read as 7 by 8 by 21. And why is that? Well, it's just more math notation. So the reason that you write the multiplication sign is because if you want to find the volume of it, you multiply. So they like to say 7 by 8 by 21 using multiplication signs instead of the word by. So find the volume of a rectangular rod with those dimensions. So again, that's the same problem we did before. So volume equals length times width times height, and plug those numbers in and calculate. Pause the video, try that problem, and when you're done, we'll come back and do it together. All right, volume. Let's go over here. Volume equals length times width times height. Length is 7. Actually, it really doesn't matter which is which. And 7 times 8 is 56. Now let's do that multiplication up here. 56 times 21. All right, so we get 1,176. So we don't have to worry about the decimal because these numbers are not decimals. So the volume is equal to 1,176 inches cubed. So if you got that right, that answer, good job. Let's go on to the next one. Now we have one more problem where we're going to find the volume of a rectangular prism. And again, you're probably thinking, why are we doing so many problems with the volume of a rectangular prism? Well, it's just a really important formula that you're going to have to know. So we did about 5 or 6 problems there. So this is the last one we're going to do for a rectangular prism. And then the next problem, we're going to learn how to find not the volume of a rectangular prism, but the surface area of a rectangular prism. But don't worry about that now. Let's do number 33, one more example here. The difference with 33, let me make sure that paper doesn't disappear. Sorry about that. The difference with number 33 is that we're given fractions. So don't panic. It's just the same formula. Volume equals length times width times height. Maybe we should read the problem first. Find the volume of an office building in the shape of a rectangular prism with the length 1/7 of a kilometer, width 2/9 of a kilometer, and height 1/10 of a kilometer. So volume equals length times width times height. The length is 1/7. The width is 2/9, and the height is 1/10. So as you can see, even though we have fractions, it's the same procedure here. We're just plugging in the numbers. I'm going to skip a line so that I don't run into those numbers. All right, so now we're going to review multiplying fractions. The good news is multiplying fractions is easy. Remember, adding and subtracting fractions, that was not so easy, but multiplying fractions, that's going to be pretty easy. So when you multiply two fractions, 1/7 times 2/9, you just multiply the numerators, and that becomes the numerator of your product. 1 times 2 is 2. And you multiply the denominators, and that becomes the denominator of your product, which is 7 times 9 is 63. So 2/63. 1/7 times 2/9 is 2/63. So now we have to multiply 2/63 times 1/10. So same procedure. I don't really need to show the work. 2 times 1 is 2. And 63 times 10 is Well, remember, whenever you multiply a number by 10, you just, whenever you multiply a whole number by 10, you just add a 0. So that would be 630. Now, if you multiply 6.3 times 10, then you don't add a 0, you just move the decimal one place over. But technically, that is what we're doing, because the decimal is on the 63. The decimal is here, so we moved the decimal one place over. We had to add a 0 for a placeholder. Again, these are things that you really need to start understanding at this point. If you're not understanding at this point, then we're going to review this before we take our final exam. We're going to take one more test, the third test, and then we're going to review everything in the final exam. So we are going to review this stuff, but you need to start kind of psychologically accepting that you're going to need to know these things. So now we have 2 over 630, but we can't leave that there. We got to, normally I would just let you leave that, but the problem is that the fraction is not reduced. It's not in lowest terms. Normally I would just let you leave it because the numbers are so big. But this is actually pretty easy, because if remember the fundamental principle of fractions, if we multiply both sides by the same number, we get an equivalent fraction. Or if we divide both sides of the fraction by the same number, we get an equivalent fraction. So in this case, we can divide both sides by 2. It's really easy. If you divide the top by 2, 2 divided by 2 is 1. And 630 divided by 2, well, you just cut 630 in half. It's no big deal. Half of 600 is 300, and half of 30 is 15, so it'll just be 315. Now, if you had trouble doing that, don't worry about it. Again, the purpose of this class is not to review this type of stuff. The purpose is to just learn the order of operations and geometric formulas. So now we have to write kilometers cubed, cubic kilometers. All right, so now we're done with finding the volume of a rectangular prism. Now let's find the surface area of a rectangular prism. We're just going to do a few more geometric formulas, and then we're going to be done for the day. We found the volume of a box in the previous problems, but now we're going to find surface area. Area is 2 dimensions, so surface area is not measuring the space inside the box. Surface area is measuring the sides of the box. How big is this side? How big is this side? How big is this side? So we're actually measuring area of a rectangular prism, not the volume. So what you have to do is you have to put squares inside this side, and that's one side, and then there's another side on the other side of the box. It's exactly the same, so that's why you have to multiply 2 times the height, and you have to measure this side, and there's another side on the bottom that's exactly the same. So that's why you have to multiply 2 times the width, and so on and so forth. So you remember how to find the area of a rectangle. This length here is 8. This length is 7. So to find the area of this side, you multiply 8 times 7. We've done that many, 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 many times. If I take this side out, if I take this side out and draw it over here and rotate it, it's just going to be a rectangle with side 7 and side 8. So to find the area, you just multiply these two together. Remember that? Again, if you're not understanding this stuff, that's okay. This is not the primary purpose of this class. But I don't want you to be completely clueless of what the formulas that we're using. So you multiply the height and the length to get this side. You know what? I just realized that this formula is incorrect. Sorry about that. I plug in the right formula here. Length times height. I didn't even realize that formula was incorrect. All right, and let's see here. What else is width and length? Sorry about this. Sorry for the delay here. Width and length, and width and height. All right, that's the correct formula there. It's kind of a complicated looking formula there. Let me make that more compact. All right, so that's the formula. So we're going to find the area. We multiply the height by the length to get this side. So height times length. But then there's another side on the other side of the box that's exactly the same. So we have to multiply it by 2. And we have to do the same thing for all the other sides. We have to take the width times the length, which gives us this top and the bottom. But because there's a top and a bottom, we have to multiply by 2. So again, that's where the formula comes from. But again, if you don't understand that, it's not a big deal at this point. So that's the formula we're going to use. Let's try a practice problem. Find the surface area of a suitcase in the shape of a rectangular prism with height 11 feet, width 9 feet, and length 3 feet. So we're not finding the volume. We're finding the surface area. So let's write the formula. A equals 2 times length times height. It doesn't really matter which order you do here. You know what, I'm just going to copy that, let me see here, length, height, width, length. I want to do it in the same order. It doesn't really matter what order you do it in. But I don't want to confuse you by writing a different formula. All right, so there's the formula. So now we're just going to plug in the numbers. I know it looks like kind of a nasty formula. 3 is the length. The height is 11. Width is 9. Length is 3. Height is 11. Width is 9. So all I did was just plug in the numbers there. All right, 3 and 11. I want to make sure I'm plugging all these numbers in. There's a huge potential to make a mistake here, plug in the wrong number. I think I got those all plugged in correctly. All right, so now we just perform the operations. These are going to be pretty easy because they're fairly easy numbers. 2 times 3 is 6. And let's go ahead and do a lot of these operations at the same time because we're running out of room here. So 2 times 3 times 11, that would be 2 times 3 is 6. 6 times 11 is 66. Again, sometimes you can do more than one operations at once. 2 times 9 is 18. Actually, I'm going to have to do this multiple steps. 2 times 11 is 22. So I'm kind of just doing, various steps at the same time. 8 times 3, you can do that off to the side if you want, but we don't really have time at this point, so I'm just going to do that in my head. So 18 times 3, that would be 54. And 22 times 9 would be 198. And so now we just have to add these numbers up. So let's go ahead and line them up over here. Remember, we can add up 3 numbers or 4 numbers or however many numbers we need. We just have to line them up properly. Remember, make sure the one digits are on the ones are all lined up. The tens digits are all lined up, so on and so forth. If you don't line them up correctly, you're guaranteed to get the wrong answer. 6 plus 4 is 10, plus 8 is 18. Carry the 1. 1 plus 9 is 10, plus 5 is 15, so on and so forth. So it'll be 21, and we have 228. So 228. Now this is area. This is not volume, so we have to write feet squared. You measure area in squares. And I know what you're thinking. You're thinking, why is it that we call it square with a 2? Well, we'll talk about that later. It's not important at this point. All right. You know what? I just realized I did that incorrectly. 18. Yep, I did that incorrectly. It's a good thing I caught that. That should be 318. If you make a mistake, no big deal. Just go back and fix it. The more calculations you do, the more potential to make a mistake. All right, so number 35. Why don't you try number 35, and when you come back, we'll do it together. All right, we're back. Most important thing is to write that formula. Show the tool that you're using. Second step is to plug in the numbers. Now this is going to be kind of tricky plugging in these numbers, I just realized. Because they don't tell us which one is the width and the length and the height and all that stuff. Let's call this the length and this the width and this the height. Actually, call that one height. This would be 3 times 4. Now we have height and width. So it doesn't really matter which ones are length, height, and width. You just have to have different combinations of numbers here. I have the 3 and the 10, the 3 and the 4, and the 10 and the 4. Make sure the numbers are different combinations. I know this is kind of confusing. All right, so 2 times 3 is 6, 6 times 10 is 60. 2 times 3 is 6, 6 times 4 is 24. 2 times 10 is 20, 20 times 4 is 80. All right, that looks correct. Now we'll go ahead and add these together. You can probably add these together in your head, but we'll go ahead and line it up here. Add the first numbers, and then last numbers. We have 164. Now notice that there are no units on this problem. I didn't put any units, so that means you don't need units in your answer. So if you got 164, good job. Just be aware that there's a lot of room for error when you're writing this formula. You got to plug in the numbers correctly. And it's hard because they don't actually tell you which one's length and which one's height and which one's width and all that type of stuff. But it's important to understand that all these expressions are pretty much the same. They all have 2's in them. The only difference, you have to make sure that you have different combinations of letters. You have the L to W, the L to H, the L to H, the L to W, and then you have the H and the W. That's the most important thing. So don't get confused there. It's very easy to get confused. Find the surface area of a closed box with dimensions 3 inches by 5 inches by 9 inches. All right, why don't you try this one? And again, if you're getting confused, you can label it length, width, height, or however you want to label it. Doesn't matter which is which. Just make sure that you stick to the labels once you decide which is which. All right, so we're back. Find the area. The area formula is so, like so. All right, and plug the numbers in. Again, there are different ways to plug the numbers in, so you can do it however you want to do it. Just make sure you have different combinations of the numbers. So I have 3 and 5 here. I have 3 and 9 here, and 5 and 9. So I have different combinations of those numbers, and they're all multiplied by 2. 2 times 3 is 6. 6 times 5 is 30. 2 times 3 is 6. 6 times 9 is 54. 2 times 5 is 10. 10 times 9 is 90. And if you add up all those numbers, you get 144, 154, 64, 174. Now in this problem we have units, so you got to put inches squared because we're measuring area. Surface area is area. Whoops, that should be 174. Sorry about that. All right, so on to the next problem. So now we're going to learn the perimeter of a circle. We did one problem like this already in I think a word problem we did a ways back. But now we're going to go ahead and go over this again in more detail. So the perimeter of a circle, that's just measuring the length around the circle. So this is one-dimensional. So notice we have a circle, so we have to have the 3.14, that number called pi. That comes whenever you have anything relating to a circle. So the formula to find the perimeter around a circle, also called the circumference, and that's the word you're going to hear from now on. It's called circumference. The formula is 2 times 3.14 times the radius. Now we talked about the radius is the distance from the center to the side, but you can also come up with the formula that gives you that shows you how to find the circumference using the diameter. The diameter is the length from one side of the circle through the center to another side of the circle. So as you can see, the diameter is just 2 times the radius. You have one radius and another radius that equals the entire diameter. So this formula is the easiest, but just understand very clearly that you're going to get word problems where they give you the radius and you have to use this formula, or they'll give you the diameter and you have to use this formula. So there's 2 different formulas. Or if you want, if they give you the radius, you can just times it by 2, times this radius by 2, and then use this formula, which is probably the easiest way to do it. So we see the approximate sign. It has to be approximately equal to because it's 3.14. So let's do some practice problems. Linda wants to make a fence around a circular garden. Approximately how many feet of fencing should she buy if the diameter of the garden is 87 feet? So at this point, you're pretty experienced with these formulas and how to do all the math. So why don't you go ahead and try 37, and when you come back, we'll do it together. All right, we're back. So we're given the diameter, so we can use the following formula. And diameter, so we're showing which tool we're using. Diameter is 87 feet. And so now we just multiply. And we count 2 places over, 1, 2. And the circumference of the circle equals 273.18. And it's going to be one dimension. So we don't put a 2 and we don't put a 3. It's just one dimensional. So if you got the right answer, good job. If you didn't, that's okay. Go back and figure out what you did wrong. If a crater has a radius of 3.6 kilometers, approximately how many kilometers would a person have to walk to explore the edge? A crater is what's left when a comet hits the Earth. It's just a big old circle if you haven't seen that. So if you want to walk around it, around the edge, you have to figure out how far you're going to have to walk. That's one-dimensional. But the key thing to understand is they don't give us diameter in this problem. They give us radius in this problem. They give us the radius. So we have to either multiply the radius by 2 or we have to use this formula. So I'm going to go ahead and use this formula. So write the formula you're going to use. Circumference is equal to, or approximately equal to, 2 times 3.14 times r. So again, that tells the reader what tool you're using. And the reader, of course, is going to be your teacher, whoever that may be. All right, so now we're ready to plug in the number. R, they tell us, is 3.6. All right, so let's go over here. We're going to multiply 3.14 times 2. And I'm going to go ahead and just do that in my head because that's a fairly easy calculation, but you can do it on paper if you want. 2 times 3.14 is 6.28. And now we're going to multiply 6.28 times 3.6. When you're multiplying, you don't have to line up the decimal. So our final answer is 22.608 kilometers. So if you got the right answer, good job. I don't remember if I told you to do that one on your own. Now, in these problems, it's always good to go over and figure out if your answer actually makes sense. If you just estimate this as 3, 2 times 3 is 6, and then 6 times, we'll just estimate this as 4, 6 times 4 is 24. So our answer should be roughly 24, and it's pretty close to 24. Now if you got 226, that would be ridiculous. Obviously you put the decimal in the wrong place. So that's a really important way to make sure that you're doing the problem correctly. All right, so now we're going to go on to the next problem here. That was circumference of a circle. Now we're going to learn the volume of a cylinder. So here's the volume of a cylinder. 3.14 times the radius squared times the height. A cylinder is like a soda can. If you've ever drank anything out of a can, or maybe you had you have some food cans in your cabinet, that's a cylinder. So the radius, you see you have circles on the top and the bottom. The radius of the circles is this value here, and the height is this length. So you just plug those numbers in, and that gives you the volume of the cylinder. So why don't you try number 39. And again, we have circles, so you have 3.14. Try 39. Plug in the radius and the height, and remember to write your original formula. And when you're done, we'll come back and do it together. All right, we're back. volume is approximately equal to 3.14 times r squared times height. We're just rewriting the formula. Then you plug in the numbers that they give you. R is 3, and the height is 6. We have to do the exponents first. 3 to the second power is 9. Then we got to move left to right. So 3.14 times 9 first. We can do that over here. And we get 28.26. We have to multiply 28.26 times 6. And we get 169.56, and that should be inches cubed because it's volume. Remember, you put a 2 there if it's area, you put a 3 there if it's volume, so on and so forth. All right, so let's see if our number makes sense. You estimate that's 9, and then times 3 is 27 times 6. That should be a pretty big number. So it seems like we put the decimal in the right place. So if you got the right answer, good job. Number 40, what is the approximate volume of a cake in the shape of a cylinder with length 4 centimeters and a radius of 1 centimeter? So in this case, we're calling it the length, but it's actually the height if you set it up so it's resting on the circular portion. So volume is approximately equal to 3.14 times r squared times 8. So we're just using the same formula we used before. And the radius is 1. And the length, which is the height in this case, is 4. So we do the exponents first. So you tell me, what is 1 to the second power? A lot of students will say 1 to the second power is 2. It's not 2. 1 times 1 is 1. Why did you multiply 1 2 times? Because there's a 2 there. So 1 to the second power is 1. So 3.14 times 1 is just 3.14. Any number times 1 is just the number. And then 3.14 times 4 . 12.56. And it's going to be feet cubed, cubic feet. All right. Approximate the volume of a cylinder with diameter 8 inches and height 10 inches. Now, this is a trick problem. It's a trick problem because they're not giving us the radius. This formula tells us how to plug in the radius, right? R is the radius. We do not have the radius. They're giving us the diameter. So how do we do this? Well, remember, if you have some sort of a circle, the radius is half of the diameter. So this line is the diameter, this line is the radius. So we have a formula that uses radius, not diameter. So we have to take the diameter, maybe I should just leave that up there. We have to take the diameter, which is the diameter is 8 inches. And we have to divide that by 2. So 8 divided by 2. A radius is equal to 8 divided by 2, which is 4. So the radius is 4. We'll just put that over there. So now we're going to plug in 4 to R, not 8. So that's a trick question. All right, so now we just follow order of operations again. 4 to the second power is 16. And 3.14 times 16, let's do that over here. Make sure those numbers are lined up, or you're guaranteed to get the wrong answer. All right, so now we have 52 or 50.24. These numbers look familiar. We had the same type of numbers earlier. It's not the same problem though. And now we're multiplying 50.24 times 10. There's good news. If you multiply a number by 10, all you do is just move that decimal one place over. So that would be 502.4. And it's volume, so it would be cubic inches. All right, so now we're going to do one more formula. We're going to try the volume of a cone. You know what? We're kind of running a little late here. This class is starting to become a little long. So let's skip the volume of the cone, and you can just do that for homework. But you can, when you do the homework, make sure to come back and look at this formula for the volume of a cone and use that formula. Or you can just look on the internet, but it's probably best to use this formula because that has the type of notation that we're used to. And as you can see, the volume of a cone is exactly the same as the volume of a cylinder. No difference whatsoever, except you divide by 3. Because if you take a cylinder looks like this, but as you can see, there are kind of 3 parts in there, so that's why you divide by 3, because you want the volume of the cone, not a cylinder. So when you do the homework, go back and use that formula. All right, so good job. That was kind of a long class. I didn't really mean it to be quite that long. So we did quite a bit. We learned the order of operations agreement. We learned geometric formulas. And we reviewed multiplying and dividing decimals and multiplying fractions and so on and so forth. So here's your homework. You can get a screenshot of that, or you can get a screenshot of this. Get a screenshot of this. And as you can see, as usual, you have all the answers there, and the reason you have your answers is because you need to check your answers for every problem. Now, remember to write the original problem, show every step, number all your problems, so on and so forth. I don't need to remind you, you already know this stuff. And when you use the formula, now all the formulas are going to be in the class, so you have to go back to the class or to see what formulas to use. Go back and watch the video to see what formulas to use. And whenever you use a geometric formula to find the area or the perimeter or whatever you're looking for, you have to write that formula down. You have to write it down again to show which tool you're using. So that was kind of a long class. I'm proud of you for getting through that. And I'll try to keep the classes shorter in the future. But that's it for this class, and I'll see you in class 24.